Let us begin with chapter 1. How does one become a mathematician? There are many ways that this can happen. Let me tell you how it happened to me. It might surprise you, but I hated math when I was at school. Well, hated is perhaps too strong a word. Let's just say I didn't like it. I thought it was boring. I could do my work, sure, but I didn't understand why I was doing it. The material we discussed in class seemed pointless, irrelevant. What really excited me was physics, especially quantum physics. I devoured every popular book on the subject that I could get my hands on. I grew up in Russia, where such books were easy to find. I was fascinated with the quantum world. Even since ancient times, scientists and philosophers had dreamed about describing the fundamental nature of the universe. Some even hypothesized that all matter consists of tiny pieces called atoms. Atoms were proved to exist at the beginning of the 20th century, but at around the same time, scientists discovered that each atom could be divided further. Each atom, it turned out, consists of a nucleus in the middle and electrons orbiting it. The nucleus, in turn, consists of protons and neutrons, as shown on the diagram below. And what about protons and neutrons? The popular books that I was reading told me that they are built of the elementary particles called quarks. I liked the name quarks, and I especially liked how this name came about. The physicist who invented these particles, Murray Gell-Mann, borrowed this from James Joyce's book Finnegan's Wake, where there is a mock poem that goes like this: 3 quarks for a muster mark. Sure he hasn't got much of a bark, and sure any he has, it's all beside the mark. I thought it was really cool that a physicist would name a particle after a novel, especially such a complex and non-trivial one as Finnegan's Wake. I must have been around 13, but I already knew by then that scientists were supposed to be these reclusive and unworldly creatures who were so deeply involved in their work that they had no interest whatsoever in other aspects of life such as art and humanities. I wasn't like this. I had many friends, liked to read, and was interested in many things besides science. I liked to play soccer and spent endless hours chasing the ball with my friends. I discovered Impressionist paintings around the same time. It started with a big volume about Impressionism, which I found in my parents' library. Van Gogh was my favorite. Enchanted by his works, I even tried to paint myself. All of these interests had actually made me doubt whether I was really cut out to be a scientist. So when I read that Gell-Mann, a great physicist, Nobel Prize winner, had such diverse interests, not only literature but also linguistics, archaeology and more, I was very happy. Impressionism was a 19th century art movement characterized by relatively small, thin yet visible brushstrokes, open composition, emphasis on accurate depiction of light and its changing qualities, often accentuating the effects of the passage of time, ordinary subject matter, unusual visual angles, and inclusion of movement as a crucial element of human perception and experience. Impressionism originated with a group of Paris-based artists whose independent exhibitions brought them to prominence during the 1870s and 1880s. They were radicals in their time, violated the rules of academic painting, constructed the pictures from freely brushed colors that took precedence over lines and contours. This is an impressionist picture, and this was the academic way of painting. Here we can see that it's like they are static images, and the lines and it's all clear. There is no blur. Same is the case here. I mean the light is diffused, but the main subject matter of the painting is clear here as well. But in this case, the subject is blurry. This is how the Impressionists are different from the academic painters of the time. These are the works of Vincent van Gogh. Based on the pictures, he seems like a natural painter. He paints what he sees. Let's move on. According to Gell-Mann, there are two different types of quarks, up and down, and different mixtures of them give neutrons and protons their characteristics. A neutron is made of two down and one up quarks, and a proton is made of two up and one down quarks, as shown on the pictures. I guess in this case, the words up and down have nothing to do with the words we are familiar with. I guess it will be easier if we just take them to mean some property, some random property that we indicate by the words up and down. What exactly those properties are, we'll discover later. That was clear enough. But how physicists guessed that protons and neutrons were not indivisible particles but rather were built from smaller blocks was murky. The story goes that by the late 1950s, a large number of apparently elementary particles called hadrons was discovered. Neutrons and protons are both hadrons, and of course, they play major roles in everyday life as the building blocks of matter. As for the rest of hadrons, well, no one had any idea what they existed for or who ordered them, as one researcher put it. There were so many of them that the influential physicist Wolfgang Pauli joked that physics was turning into botany. Physicists desperately needed to rein in the hadrons to find the underlying principles that govern their behavior and would explain their maddening proliferation. I guess the joke means that since there are 375,000 species of plants, with more being discovered, the number of hadrons seems as humongous as the plants being discovered. Since the number of hadrons was so high, and physicists generally want a simpler picture of the universe, they were trying to find something even more fundamental. Gell-Mann and independently Yuval Neeman proposed a novel classification scheme. They both showed that hadrons can be naturally split into small families, each consisting of 8 or 10 particles. They called them octets and decuplets. Particles within each of the families had similar properties. In the popular books I was reading at the time, I would find octet diagrams like this. So these are the hadrons that belong to one family. Here the proton is marked as P, the neutron is marked as N, and there are 6 other particles with strange names expressed by Greek letters. This is sigma. So we have seen lambda and chi. So we have neutron, proton, sigma minus, sigma naught, sigma plus, lambda naught, chi minus, chi naught. Here the proton is marked as P, the neutron is marked as N, and there are 6 other particles with strange names expressed by Greek letters. But why 8 and 10 and not 7 and 11 say? I couldn't find a coherent explanation in the books I was reading. They would mention a mysterious idea of Gell-Mann called the Eightfold Way, referencing the Noble Eightfold Path of Buddha, but they never attempted to explain what this was all about. So that's it for today.